In this video, we're going to talk about ratios, rates, and unit rates. Let's start with ratios. A ratio is a comparison of two quantities using division. And just like fractions, ratios are usually reduced so that they can be written in the simplest form. The key word about ratios is comparison. So let's say I want to compare my red triangles to my purple triangles. There are 4 red triangles and there are 6 purple triangles. So my ratio is 4 to 6. The order is important because I wanted red triangles to purple triangles. So red triangles needs to come first. There are 3 ways I could write this ratio. I could write it with a colon. I can physically write the word 2 in the middle. Or I can write it like a fraction. Now the last thing is, I said that ratios are usually written in simplest form. So we would need to write this as like it were a fraction written in simplest form. So let's see. 2 goes into both of these numbers. 2 goes into 4 twice. 2 goes into 6 3 times. And so an equivalent ratio would be 2/3, except 2/3 is written in simplest form. Now I'm going to give you a quick way to check and make sure that you do have equivalent ratios, that they're equal, that they're the same value. If I multiply the cross products, 4 times 3, if I multiply to find the cross products, 6 times 2. 4 times 3 is 12. 6 times 2 is 12. Since the cross products are equal, I have equivalent ratios. Let's look at another example. Let's say I want to compare my moons to stars. The moons are the black dots. The stars are these. You might not be able to tell that they're moons and stars, but I'm telling you. If I want to compare moons to stars, I'm going to count them up. I've got 6 moons and 4 stars. I like to write that one as a fraction, but you could also do that. You could also do that. Now 6 to 4, that's not in simplest form. So let's go ahead and reduce it. 2 goes into both of these numbers. 2 goes into 6 3 times. 2 goes into 4 twice. So I have an equivalent ratio. It has the same value, but it's written in simplest form. Let's just double check to be sure. Cross products. 6 times 2 is 12. 4 times 3 is 12. So I know they're equivalent. Let's try another one. I want to compare the number of stars to the total number of shapes. If I count up, it looks like I have 4 stars. And there are 10 total shapes. Notice that the problem didn't ask me anything in particular about the moons, but I did need to use the moons to figure out the total number of shapes I have. So my comparison of stars to total shapes is 4 to 10. Now, I don't think that's in simplest form, so I'm going to simplify them. 2 goes into 4 and 10. 2 goes into 4 twice. 2 goes into 10 5 times. So an equivalent ratio is 2/5, but it's written in simplest form. Let's double check and make sure. 2 times 10 is 20. 4 times 5 is 20. So my cross products are equivalent. All right, now let's talk about rates. Rates are a special type of ratio where we're still comparing two quantities, but they have different units. So this is a rate. If I ate 45 oranges in 5 minutes, that would be a rate because oranges and minutes are different units. 18 miles in 30 minutes would be a rate because I'm comparing two different things, miles and minutes. Now, a special kind of rate is called a unit rate. And for a unit rate, this is where you have a denominator of 1. We're trying to find the rate for 1 of something. And it's kind of easy to remember. The word unit starts with the prefix un, which means 1. So let's look at an example. If I have 45 oranges in 5 minutes, the unit rate would be for me to figure out how many oranges I could eat in 1 minute, because that would be a denominator of 1. So let me think. To get from 5 to 1, I divide by 5. So if I divide the bottom by 5, I have to be fair. I'm going to divide the top by 5. 45 divided by 5 is 9. And so I can eat 9 oranges in 1 minute. Now let's just use cross products to make sure that I made an equivalent ratio. 9 times 5 is 45. 45 times 1 is 45. So I know I made an equivalent ratio. Let's try another one. I can run 18 miles in 30 minutes. For a unit rate, I would want to know how far I can run in 1 minute. So let's see. To get from 30 minutes to 1 minute, I divide by 30. Since I divided the bottom by 30, I have to be fair. I have to do the same on the top. 18 divided by 30 would be 0.6. So my unit rate is that I can run 0.6 miles in 1 minute. It's still a rate because I have two different things that I'm comparing with different units, and it's still a ratio because I'm making a comparison. But it's a special kind, it's a unit rate because of the 1 minute. All right, I have some unit rates for you to practice. Why don't you try to find the unit rates of these three? You can pause the video, and then when you start again, I'll be writing the correct answers up here so you can check yourself. All right, so we started with 3 different rates, and we found the unit rate by going from 8 hours to 1 hour, from 5 minutes to 1 minute, from 18 hours to 1 hour, to see how much it costs for just one, or to see how long it takes to download just one song, the unit rate. Okay, last problem, we have a little challenge problem to end us up. So, we have a cat and a horse. A cat's heart beats 3,600 times every 30 minutes. A horse's heart beats 1,320 times every 30 minutes. I want to know how many more beats a cat's heart beats in 60 minutes. So since they're asking how many more, I know I need to find the difference. So in 30 minutes, I'm going to find the difference for the two animals. So cat is more. All right, so a cat's heart beats 2,280 times more than a horse's does in 30 minutes. However, that is not the question. The question is asking us for 60 minutes. So let's make an equivalent ratio that has a comparison for 60 minutes. So let me think. To get from 30 minutes to 60 minutes, I just double it. Multiply by 2. So if I multiply the bottom by 2, I'm going to multiply the top by 2, which would give me 4,560 beats more in 60 minutes. Thank you.